Now we're going to talk about units. Units are really important. So here's a sentence. When my son was 7, he walked 3, and when he was 4, he threw his baseball 8 and said his school was 5 away. Does that make much sense? No. What's missing from that sentence? The units. Units are very, very important. There was, I think it was a spaceship that was supposed to orbit Mars. Cost millions of dollars, right? So it gets up there, begins to orbit, gets too close, the orbit decays, and it crashes. Because of units. A group of what would they be? Rocket scientists, right? One group was using the English system, inches, and one was using the metric system, centimeters, and they did not communicate that well to each other. And because of that, the calculations ended up being incorrect, the orbit was wrong, and the spaceship was lost. Units matter. And we need to write the units down every single time. Units can actually save you from making a lot of mistakes. The two most common unit systems are the English system and the metric system. Scientists use the international system of units. It's called the SI system. You might say, well, why isn't it the IS for international system? Well, it's SI because of the French. In French, the international comes after the system, much like it does in Spanish and many other languages. So this SI system is based on the metric system. It is not exactly the same as the metric system, but the units are the same. And so there is this difference, but I don't consider that difference to be important for this class at all. So we're just going to call it the metric system. I'm just telling you about this SI system because you should know that it exists. An example, these are standard units, and the standard unit of mass is the kilogram in the SI system. In the metric system, the base unit of mass is the gram. Is that a huge difference? No, it's not. So we're going to look at these units. The meter is the unit of length. And this is how they define what a meter is, if you're interested. A meter is about the same distance as a yard. Is there a... No, there isn't. Because this is just a lecture hall. Normally there's a meter stick. But you guys know how long a yard is, right? It's about this long. Very close to that. It's helpful to have a ballpark idea of how big these units are. For mass, the standard unit is a kilogram. This is a picture of the official kilogram. There's a block of metal, and they keep it under very controlled conditions so it's not going to, rust or have anything happen to it. That's the kilogram. A kilogram is about 2.2 pounds, so roughly 2 pounds. That gives you an idea of how big a kilogram is. Standard unit of time is the second. That is exactly the same second that we use in everyday life. It's just defined in a very, very fancy way. It's defined by the radiation from a particular transition of the cesium-133 atom. I am not quizzing you on these definitions of these units. Kilogram is a unit of mass. Mass is similar to weight, but it's different. In everyday life, we talk about weight. How much does this weigh? How much do you weigh? How much weight did you lose, right, or gain? Mass measures quantity of matter. Weight measures the gravitational pull on that matter. So if you weigh 100 pounds on Earth, and you take your bathroom scale and you go to the moon and you stand on the bathroom scale, is it going to show the same weight? No, it isn't. Because the moon is smaller and its gravitational pull is smaller. It's about 1/6 of the gravitational pull of Earth. So your weight on that scale will be less. Does that mean that you're smaller? That you're going to fit into those really skinny jeans? No. The amount of matter in your body is the same. It's just that you went to a different, it's not a planet, but you went to a different celestial body, and the gravitational pull is different. So it's important to understand that there is a difference between mass and weight. As long as we stay on the planet, we can use the terms interchangeably and not get into trouble. Anybody planning to leave Earth during the semester? No, I didn't think so. So kilogram. The gram is another common unit of mass. We'll see how it's related to the kilogram. Gram is a smaller unit, and it's much more useful for chemistry because we don't like to deal with huge quantities of chemicals. We try to deal with smaller amounts. So the SI system and the metric system use prefix multipliers to change the size of the units. So let's talk about length. What are English units of length? Inches, feet, yards, miles, right? Why would I not want to measure this piece of paper in miles? Because the unit is huge, right, compared to the thing. It's convenient to use a unit that is similar in size to what we're measuring. So we could use feet to measure this piece of paper, but we typically use inches. And so this piece of paper is 8.5 inches by 11 inches. And so we end up with nice, manageable numbers. Now, if we're measuring the distance between here and Fresno, do we want to measure that in inches? No, because that's going to end up being a huge number, and it's just awkward. So we like to use a unit that's similar in size to what we're measuring. So what's the relationship between inches and feet? 12 inches in a foot. And how many feet in a mile?
5,000 and change.
Yeah, 5,280. Where did they get these numbers? They're pretty random seeming, aren't they? That's because the English system came up with people just using everyday stuff to measure. A foot at one point was defined as the length of the king's foot. And so these measurements have these kind of random, very interesting historical definitions, but they don't work very well in modern science. The metric system, instead of having all these random numbers relating the unit sizes, just has factors of 10. And so we have these prefix multipliers to make the units bigger or smaller to suit what we're measuring. So these are the metric prefixes: tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico, and femto. There are others, but these are the most common. They all have one letter, symbol, abbreviations, and then they have mathematical meanings. So if we take kilo, for example, the abbreviation is K, and kilo multiplies the unit by 1,000. So a meter is about a yard. A kilometer, a kilometer, is 1,000 meters. That makes it more in the ballpark of a mile and makes it useful for measuring the distance, say, between Tulare and Fresno. If we need meter to be smaller, maybe so we can measure the width of a fingernail, we use a prefix maybe like centi or milli that makes it smaller. So a millimeter is 1/1000th, 0.001 meters. Hang on a minute. So this is equal to 1/1000. And this is 1 over 100, and this is 1/10. You get the idea. These decimal forms get a little tedious. I mean, can you tell me, just looking at that, how many zeros there are? You actually have to get your finger out and count. It's real tedious, right? So I find it much better to think of these in terms of factors of 10. So 1,000 is 10 to the third. We talked about things like that on Tuesday. And 1/10 is 10 to the minus 1. 1/100th is 10 to the minus 2. 1/1000, missing a 0. 1/1000 is 10 to the minus 3. Then we get 10 to the minus 6, 10 to the minus 9, 10 to the minus 12, 10 to the minus 15. You should memorize these prefixes and what they mean. Like, oh. Well, I'm going to show you the most important ones. Micro, milli, centi, and kilo. Those are the most important ones. I'd like you to take a shot at memorizing all of them. So kilo is a K, and it multiplies the unit by 10 to the third. Centi is represented with a C, and it multiplies whatever you put in front of it, put it in front of by 10 to the minus 2. And milli is 10 to the minus 3, and micro is 10 to the minus 6. You'll notice that there are 3 of these prefixes that start with the letter M: mega, milli, and micro. Mega makes it bigger. You sometimes hear, well, that guy's making megabucks. What does the prefix mega mean? It means a million. So megabucks is million bucks. Mega makes it bigger. It's a big M, a capital M. Milli is a prefix that makes the unit smaller. It's a small m. Then there's micro. Well, we only have 2 forms of M in the English alphabet, so then we slip over into the Greek alphabet. And this is the lowercase Greek mu, which is the version of M. It's like a U with a long tail on the front. It kind of looks like a backwards Y. That's mu. So, an example. A short chemical bond is about 1.2 times 10 to the minus 9 meters in length. What prefix multiplier would be useful to give us a unit to measure this bond? Let's go back to this. Is there one that is 10 to the minus 9? Yeah. So 10 to the minus 9 would be useful. So 1.2 times 10 to the minus 9 meters. Instead of times 10 to the minus 9, I can write the prefix nano. And so that is equal to 1.2 nanometers. Isn't that a nicer measurement? The unit is on the same scale of size as what I'm measuring, and so then the numbers become more manageable. So we talked about mass and length and time. There are also derived units, and these are units that are formed from other units. Many of the units of volume are derived units. If you have a box, how could you figure out the volume of the box? You could use geometry, right? The volume equals the length of the box times the width times the height. If I measured each of those in meters, meters for the length, meters for the width, meters for the height. Meter times meter times meter is meters cubed. That's a derived unit. It's a unit of volume, but it's derived from a unit of length. Many volume units are derived from length units. So any unit of length, when you cube it, raise it to the third power, becomes a unit of volume. So we see cubic meters, cubic centimeters, cubic millimeters. These all are units of volume. We typically use those units when we're measuring the volumes of solids. And we see this in everyday life too. If you go to the garden store and you're buying steer manure to put on your garden, it's probably going to be sold by the cubic yard or the cubic foot. It's a solid. But if you're buying milk or if you're measuring oil to put into a recipe, is that going to be measured in cubic inches? No, you're going to use a unit like gallon or ounce, right? It's a different set of units for liquid volumes. And so in the metric system, we also have different units for liquids, liter and milliliter. So here's one of those prefixes, right? Milliliter. 1 milliliter. Do you remember what the prefix milli means? 10 to the what? -3. So instead of writing the letter, I can write what it means, and I have a relationship between milliliters and liters. I think we all have a fairly good idea of how big a liter is, right? Can you visualize a 2-liter bottle of soda? A liter is half of that, right? So, it's a manageable size.